Testing. Excuse the is my mic still on? My fan is really high because heat issues. Alright. I can deal with the heat issues somewhat by slightly lowering the CPU speed setting, and just want to try to reduce the fan noise here because my fan noise is very high. It's still high. Yeah, so I've been just learning Vulkan a bit, and yeah, I mean it's an API. It's interesting to yeah, like if you're used to OpenGL and you think that a new API means it's somehow going to become simpler to do low-level 3D programming, it's kind of the opposite. It's like almost a little bit. It's like 3D APIs, the low-level APIs are becoming more complex, which makes sense because hardware has become more complex. Like compared to 15 years ago, like you would just have a CPU, and then maybe you'd have a graphics card, which just never had a GPU, but just drove the video. And maybe could do some stuff like draw triangles quickly. But then, you know, GPUs, once GPUs started coming out, the graphics processor became more of a full-on processor of its own. So systems are, and also then what's really common these days, which wasn't common 15 years ago, is CPUs having multiple cores. Like, and even a cheap, like a really cheap phone has multiple cores these days. Like, I bought a really cheap phone that was like $50 or $100 phone the other day, and it had 4 cores. You know, so Vulkan is designed to be able to better distribute the load across multiple cores. So if you have either, say, systems like phones where you have 4, you know, it's common to have a 4 CPU ARM architecture thing, or, you know, like this laptop, for example, has a CPU and GPU. There's an Intel CPU, NVIDIA GPU. The Intel CPU is an integrated Intel thing, and then it's got a proper GPU, which is an NVIDIA thing. So so Vulkan is basically designed to, you know, there's bottlenecks in the design of OpenGL that make, you know, a lot of things end up getting restricted to just the primary CPU that shouldn't need to be. So Vulkan is basically redesigned things to basically better allow tasks to be parallelized. But then also what they've done is they've made, you have to specify quite, you know, that you have to set up your whole rendering pipeline much more explicitly, so it actually makes you, the developer, do a little bit more work, not a little bit less work. But there's a reason for that. The application knows what it wants to achieve in terms of the design of the graphics engine and what it wants to do. So by being more explicit, in making the programmer be more explicit in setting up the rendering pipeline, allows the driver to optimize the tasks better, instead of having to kind of guess what the application wants to do, you know, and having sort of, you know, the driver's guess has to be just based on what the average application tries to do, which may not be the same as what you're trying to do in your specific application. So yeah, so basically you have to be more so explicit. Yeah, and then there's also other trends, like new things like real-time ray tracing and new hardware that Vulkan is introducing extensions to be able to do. And but yeah, I mean, these samples, like just to draw one triangle, these samples to draw one triangle are like thousands of lines of code. So yeah, but so I don't recommend everybody learns Vulkan. It's really an in-depth thing if you really just want to get into low-level API programming. Then yeah, go for it. But it's definitely not for everyone. I'm quite happy to, because that's where I'm happiest. I sit naturally. You know, I'm somewhere between low level and high level. But, you know, I like to be at least somewhere just above the hardware. Not quite at the hardware, but just above it. I still like to do high level programming, but yeah, you know, if I have to just use an engine that does all the little stuff abstracted away for you and you never have to think about it, it's not really my taste for programming. So yeah, what I wanted to try to do is just get some basic little applications running with Vulkan. So you know, I thought I could I basically have to copy big parts of the samples where they've, as kind of a template almost. I know that sounds like it's cheating. I didn't want to do that. I didn't want to end up copying big parts. But yeah, it's relatively much. Like you have to, I mean, the sample to draw one triangle is 1,300 lines of code. But that 1,300 line of code is just a little surface. It actually uses, that's not the whole thing. It's actually thousands and thousands of lines of code just to draw one triangle. A few other changes in Vulkan. They've switched to using the same coordinate system as DirectX 12. As DirectX, yeah. So historically, OpenGL had a different coordinate system to DirectX. And now they've basically adopted the same, which should simplify engine and application development, that it targets multiple. So yeah, that's what just should help simplify at least one aspect of if you're writing engines or whatever, or applications that target multiple APIs, like you want to target Direct 3D and Vulkan in a game or application, then yeah, it uses the same coordinate system. But yeah, you have to set up, yeah, you have to, you have to query what devices are available and then see what devices are available and try semi-intelligently pick a device or allow the user to pick a device. And then you have to set up command buffers, and you have to set up your what's called a swap chain, and you have to set up the semaphores and fences, which are like synchronization stuff. If you have a CPU and a GPU and have to wait, if the application has to wait for something to finish from the GPU, or you have to set up synchronization primitives for the, you've got basically multiple CPUs or multiple GPUs communicating with one another. Vulkan is also, properly multi-threaded. So yeah, there's some interesting benchmarks out there. Like, if you want to kind of understand OpenGL versus Vulkan benchmark. Benchmarks that basically render the same scene. I'm looking for one, for example. Yeah, there's one interesting one, which kind of shows the point of it. A few of them do, but I'm looking for a specific one that I was looking at. I can't find it now. Or was it this? No. It was a really flat video, the one I'm thinking of. There's a couple of them, there's a few of them that but yeah, the interesting part about it is not even the graphics, but like per se, it's that they're rendering the same scene with OpenGL. Oh, I think OpenGL ES. This is one of them now, but this is one of the ones I was watching, and there's another one. They basically render the same scene, and side by side, it looks the same, frame rate's about the same. So you think, well, what's the difference then? Why is this interesting? But then you look at the CPU or GPU distribution load. And in OpenGL, like if you've got a 4-core, you're rendering the same scene on a 4-core phone. Just about everything is being done by the main CPU, and the other CPUs are just sitting idle, which is firstly a waste. Secondly, uses more power. And also because when one CPU is really high instead of four being used, it also, the CPU gets hotter. So other extra things that use more power, like your fan kicks in. If you've got 4 cores, and if you're utilizing all of them just a little bit, the CPU remains cooler. If you use one fully, then your fan has to run. So that also draws battery. So for phones, that kind of thing also drains the battery more. So it's more. So with the OpenGL drawing the same scene, most of the load is on the first main CPU, and the other cores are sitting doing nothing. But with a Vulkan redesign, it's drawing the same scene, same frame rate, but all of the CPUs are keeping busy. So the load is distributed, across the. I'm not sure if this one shows the same thing. This one shows a similar thing. Yeah, they're rendering the same scene, but the CPU usage, so this is a plot of the CPU usage rendering the same scene, getting a very similar frame rate, but with OpenGL it's using a lot more CPU. With Vulkan it's much more CPU efficient, so the CPU leaves also the CPU free to do other things like game AI or whatever. So that's one of the points of Vulkan, even though on the surface it may not look like, oh wow, lots of sexy new 3D stuff. Per se, it's a lot of the redesign and the kind of where they're going with it makes a lot of sense when you understand that, and why, and that's also why I think it's actually a really important API, and going to remain and remain an important API. If you look at OpenGL and you're familiar with it, you might wonder, well, what's the big deal about switching to Vulkan? But if you think long term and you think, our hardware is evolving at the moment, our systems, like the new, also the new AMD CPUs, it's getting more and more common to have CPUs with they're decently designed CPUs, with consumer CPUs with 12 cores or 16 cores or 32 cores, and okay, some of them maybe not quite consumer unless you're pretty rich, but yeah, it's obviously the trend to have more and more cores, whereas we're not going to get that many, we're not going to get big breakthroughs anymore in like the gigahertz of processors, but we can increasingly have highly parallel architectures to get more out of our hardware. So anyway, that's so yeah, I'd kind of like to rewrite my little game using Vulkan, or one of the other projects I'm working on actually is more interesting than the game too. The game is not a good demonstration, Dave Newcomb. It's locked to 18 frames a second, so there's no point. Even on a laptop like this with full software rendering, that game can do like hundreds of frames a second if I unlock the frame rate. But yeah, you want to see 3D stuff. So there's a couple of interesting bunches of samples that I found. The one comes with the Vulkan SD, or not, it doesn't come with it, they don't get sets of Vulkan samples. I think one of them is now bundled with the SDK. Yeah, one of them comes with the SDK now, they've added it. It wasn't before, but now it is part of the SDK, or they've started adding more samples. And then some guy has created a crapload of samples, which are really nice. That's what I was looking at the other day. Vulkan samples. You can do get limit minus v. So to get these examples, you can do something like get clone minus recurse submodules, and then github.com /elements Vulkan. So yeah, to get these samples, that's which I'm looking at now, which I've been looking at. There's you can do basically that with git. And so yeah, I compiled these samples the other day and I'm just studying them, and this fan is apparently, yeah, this model of CPU that I have, the i7-7700HQ, or what is it? HQ, yeah. The fan noise is an issue with it, apparently. It seems to be a CPU design issue, which Intel claims is not a problem, but it really quickly gets hot, like 80, as soon as it's busy, and the fan noise becomes noisy. So anyway, right, so the other thing I'm looking at is GLFW, which is that's something worth looking at. GLFW, which is like just a little wrapper. libstl also. Yeah, right. So GLFW has integration now with Vulkan, so you can create windows using GLFW in a cross-platform way. Well, you can use GLFW to easily create a window in a cross-platform way. It doesn't do much else for you, I don't think. But yeah, it's a lightweight utility library for use with OpenGL. So it was OpenGL, but now they also added Vulkan. So GLFW allows you to create Vulkan windows also. Now, interestingly, I was looking at, so yeah, libstl2 also has Vulkan support. But I was looking at SFML. What's that other library? SFML. I wanted to create something with this the other day, but then I found a long thread where they were discussing the idea of supporting Vulkan, and the developers didn't seem too interested in supporting Vulkan, which kind of puts me off this library a little bit. I don't know, that makes me worried a bit. I don't know if they are forward thinking enough. Because Vulkan is really important. You can't just ignore it. So I'm a little bit wary now. I was gonna use SFML for a project, but I've now decided not to, because the mentality of the developers toward Vulkan seemed a bit dumb. It seemed like, what's the point? What's the point of supporting this? So yeah, that makes me nervous. I would not. You want a library that keeps up with important future things. Otherwise, 5 years from now, you write a game using it, and then 5 years from now, you need to support the newest stuff, and it's just, you have to rewrite your whole game because it doesn't. Or not rewrite the whole game, but significant parts of it. So it's important to pick the right library. So it's really important to look at all these little libraries like GLFW and libstl and see what is their attitude and their mentality toward Vulkan. Create a framework. So for each swap chain image. So this really is so much stuff you have to set up. It's almost ridiculous, but yeah. The other thing they do is they're not, for various reasons, they're not including intrinsic stuff for compiling shaders, which when you understand their reasoning, it makes sense. They use a binary, you precompile using, you can either precompile using GLSLC, the shaders, into this representation called Spur V for shaders. There is a third-party library for loading them at runtime, so you can load them at runtime if you need to or want to. But it's a third-party library, and it's not. I guess it may make sense in some instances. Yeah, whatever makes sense. So you can still choose to if you need to, but they try to discourage it, rather use precompiled. One of the problems with the letting, like the, with like the GL compiled stuff, is that it wasn't consistently handled across different hardware and different drivers and different platforms. So as a developer, you didn't have predictability. Like you say, okay, compile this shader, but one platform returns immediately, doesn't compile it, and only compiles it later when it needs it. So it makes loading faster, but all of a sudden you get glitches when the scene tries to run for the first time, because it suddenly is doing last minute compiling, or things like that. So they wanted to make it more predictable for the developers. And also, yeah, there were differences in how the different platforms would interpret things slightly differently. They wanted to just make it more standard. Yeah, I wanted to look at the samples. That's what I was doing. Set path equals CE Vulkan samples. Yeah, so it's a C library, the Vulkan SDK, but there is a C++ wrapper called Vulkan HPB. I'm not sure whether it's a good idea or a bad idea to use that. But yeah, urban percentage path percentage. So I just want to, these samples need this DLL, but some of them load data files. So I'm putting the DLL in the path by just doing that. So these are all, they're compiled 64-bit, bin release, and yeah, so this is the Sasha Willems samples, and they, I think I was looking at the file last time. Particles. So I'm just looking at all of them, just to get an overview. So all these samples, yeah, you have to use, once you get clone them, you have to use, I think, CMake to build the project file for your Visual Studio, and then you can compile them in. I compile them in just in Visual Studio using this project. Vulkan examples. Fire particle fire, and there's core code that's reused by all the samples, and then there's each sample's code. So there's like common Vulkan example base stuff, and there's a lot of stuff in here. It's almost it's not just that. What makes it a lot is also the swap chain stuff, for example, Vulkan handled HTTP. So this is like another. This is just to initialize and handle the swap chains. So it's really a lot. I didn't want to just copy stuff and say, okay, this is my application. But, you know, there's no point retyping 10,000 lines of code just to... It's not 10,000, but yeah. It's... There's just too much to do it the right way. Just cheat and copy parts of it to start one's own Vulkan application, I think. But yeah, so there are also samples that come with the Vulkan SDK. They're slightly less mature because they've only recently started adding proper samples and focusing on adding samples. But yeah, there are Vulkan examples, a lot of Vulkan examples that come, and including a triangle one, which is also about 1,300 lines of code. This is the official hello triangle that just draws one triangle. This is from the official SDK. Oh no, I can see it's the same thing. Yeah, alright, that's why it's about the same thing. Either I'm in the wrong folder. Oh yes, I'm in the wrong folder. These are the official Vulkan samples, I think. Are they? Git remote -v. Yes, Cronus group Vulkan samples. So the official samples. For the official samples, yeah, use git clone --, recurse submodules. For the official samples. So both of them have a triangle sample, and then both of them have like Vulkan cube, yeah, spinning cube is Vulkan. The SDK used to be called the Luna G SDK, but now they've rebranded it to the Vulkan SDK. Hello triangle, this draws one triangle, and it's also a lot of code. This is the official sample for drawing one triangle. And it also like reuses quite a lot of stuff. Yeah, one slightly interesting thing is that just for the purposes of the sample, for simplicity, shaders, the actual data for the triangle, which is not quite right. You know, the vertices should actually come from the, well, it depends what you're doing. There isn't really a right and a wrong. But typically, you know, your vertices would come from the application saying, I want to draw some vertices. But yeah, it depends on the design of the application. But they've literally baked the vertices into the shader, but that's just for the simplicity, and that's for the simplicity of the sample. I can feel this fire from hot CPU. This laptop's getting really hot. See, from the fire. Fire is burning my laptop up. Now, the problem with this is, what's annoying